Hello everyone. Am I audible? Hello, am I audible?
Yes, sir, you're audible.
Okay, perfect.
We'll be starting the session by 1. Participants, please do wait.
राशि का होगा।
Hello everyone.
Hello.
Hello.
Hello,
Uh,
sir. Very good afternoon.
Good afternoon.
Sir.
Okay, so till other students are joining, let's have a discussion regarding anything you guys wanted to know about IoT and you know starting up or any questions regarding previous session as well.
Sir, where can we find IoT project?
IoT projects. Okay, so internet is full of it, but I'll not recommend you to just go search for IoT projects and do some projects. Rather, what you can do is you just observe what are the problems around yourself. There are so many things that you can solve with the help of IoT. Just look out for the problems that okay, this is something that I can solve with IoT. If you understand the technology, you can use it in various areas around yourself, and you can observe the problems. Let's say if you can automate any kind of device first of all. So IoT is about automating, collecting the data. Now you have to look around yourself what kind of data that you need from the environment, and then how you can present it and how you can create an application out of it. So there can be a lot of problems that you can solve with IoT. So rather than just going on internet and searching for top IoT projects, or just scrolling through the web, I'll ask you to surf a little bit, go around in your neighborhood and find the problems, find what people are suffering from, and then try to implement IoT and try to make some hardware to collect the data or to solve that issue. So this will definitely be much better than just googling about uh, IoT projects. Top IoT projects would be like this home automation system, or the temperature thermostats, and fleet management system, agriculture IoT. So these are the projects that you will find on internet, but solving a real life problem, it's always better.
Sir,
Uh,
after for a problem, how means what are the steps means how to implement this project? Uh, that type of resources I want to know where we can find it.
uh I mean, like, again, can
Implement,
you repeat what exactly do you need?
sir, how to implement a project from scratch means uh, I just want to know.
Okay, got it. So, see, if you have attended the previous session, I've told you that how we can convert a normal device into the smart device. So that is your overall process. Once you diagnose a problem, and once you have a solution in mind, that okay, there is some let's say there is greenhouse effect. You must have heard about the greenhouses. I hope everyone is aware about greenhouses, right?
Yes.
So, so there is a problem in greenhouse that you need to maintain the temperature, and accordingly, you need to what you can do. You need to maintain the water pressure, and you need to control the speed of the fans accordingly to the temperature. So what you can do is, now you have a problem that you have to maintain the temperature throughout the greenhouse, and for that you are manually turning on the motors, you are manually turning off on the fans, and manually controlling each and everything. Now, if you observe this particular scenario, first you need to take out temperature and humidity readings from the greenhouse. Now, accordingly, what your requirements are, accordingly you have to control the fans and the water pumps. So you have like, yeah, so you have like two different things. First, you need to measure the temperature. Then you need to control the devices and like fans and water pumps according to that temperature range. So you can start by creating a device. First, a sensor will sense the data, then it will upload it on the cloud. Then again, the cloud will send commands to your different device that will control the fans and the pumps. Overall process has to be same. The device that you will be making, again, if you are working with sensors, then either it has to be solar power sensor or it has to be battery powered sensor. If you are using a battery power sensor, then previously I've told you that you are using a Wi-Fi, then you have to replace batteries once after like one month maybe, or 2 months. But if you are using Zigbee, then you can use that particular sensor for years. So that's
Already ಸಿಗುವಾಗ ಎಲ್ಲಿಟ್ಟಾರೋ.
Yes,
yeah.
sir.
Akshata, can you please mute yourself if you're okay? Thanks. So, if you are using a sensor, battery-based sensor, you can use some Zigbees or BLEs. Then once the data is collected from there, you either need a gateway, and then so it's basically a topology that you have to make, and you need to transfer this data to the cloud, and from cloud you need to make a dashboard or a mobile application for the greenhouse user, so that he can set the different temperature threshold limits, or he can manually control the fans and the pumps from the app, or the pumps and fans can be controlled automatically accordingly to the temperature. So again, this is just a basic example, and you can do multiple things.
Okay, sir. Thank you.
Sir, can you explain more about IoTNs?
IoT?
IoTNs, the platform that you have created for us.
IoTNs is it's just a website that we have created during COVID, first lockdown to, educate the students about Internet of Things. So the platform that we have created, it's SmarDen.tech, SmarDen.tech, SmarDen.tech. Don't worry, I'll share the resources and I'll introduce you to this platform today. So
Okay.
SmartDen.tech is basically, if you are from electronics and you don't know the backend part, like the cloud computing and, databases, and you don't want to code, and you don't want to create a complete mobile application or dashboard. In that case, you only need to focus on the device, and we will provide you the code for the device. We'll provide you a simple basic library for SmartDen.tech. You need to just upload that code into your device, and you can directly access your device with our SmartDen.tech platform. We are providing mobile app as well as complete IoT dashboards. So you can just monitor and control the device from anywhere in the world.
Okay, sir. Sir, and can you just share your contacts, like your mail or
Yeah,
something?
sure. If I guess if today's everything is working absolutely fine, I'll share, or maybe at the end of the workshop, I'll share all the things with Rashi, and maybe she can distribute. I'll share few programs as well, Arduino programs as well, and all the details about the platform and whatever I'll teach. I don't, not very fond of using presentations during the sessions, so I either just open this iPad thing and then I teach like that only. So I hope you guys are understanding what I'm teaching.
Yes, sir.
Yes, sir.
Thanks a lot. I think that presentations are, they are kind of boring stuff, going through all the slides one by one. So why not just, do it like this?
Yes, sir. It's more interactive thing, and yeah, we can go with this because for the past few
Thanks
years
a
we
lot.
have.
Thanks a lot. Any other questions? Okay, students are joining now. We have
So,
154 students. Let's wait for two, three
Excuse me,
minutes
sir.
more, and then we'll. Okay, so just some random chit chat with you guys. How many of you guys have hello?
yes, sir.
Sorry, the connection is a little weak today. Uh, okay, so yeah, I was asking how many of you guys have watched Shark Tank?
Pardon, sir?
Yes, sir.
Yes, sir.
Are you
Yes,
guys
sir.
watching Shark
Yes,
Tank?
sir.
Shark
Yes,
Tank
sir.
TV.
Yes, sir.
Yes, sir.
So are you guys enjoying it?
Oh,
Yes,
yes,
sir.
sir.
Yes, sir.
Yes, sir.
Perfect. It's good to see that people are, going towards startup culture and they are enjoying. Great.
Sir, I actually wanted to talk about one internship regarding IoT, sir. Like,
Okay. Yeah.
what are the opportunities like that we can get into this internship regarding IoT or the something, sir? Being an EC engineer, we are expected to have a more hardware knowledge, a better understanding of the hardware.
Yes. See,
So, yes, sir.
what generally people expect, or what I would say that what generally the industry expects from the electronic side is a combination of hardware and software. If you are electrical, people will only focus on your hardware capabilities. If you are from computer science, people will only focus on your coding capabilities. But if you are from electronics, so electronics has become such a branch where people, they search for a combination of both hardware and software, and it's a good thing. You can
Yes,
go
sir.
for either the hardware part, or you can go for either the software part. Now with IoT, it opens a lot of options in multiple streams. So hardware is one of them, obviously, so because at the end, it's always the hardware that is connected to the internet. Now software part is again, software is divided into two different categories here. One is software for the hardware, and one is software for the front end, or I would say, like, in basic layman, one is the firmware that will go inside your device. Either it is the STM microcontroller, or it is your Arduino, or ESP microcontrollers, or any Wi-Fi microcontroller. And the second, or basically the device level coding. And the second one is where you design the applications for IoT for those devices that will go on your cloud, or maybe your mobile application development. So yeah, IoT opens a lot of options for these domains. And the
Okay, sir. Thank you, sir.
best way to find out
Yes, sir.
these internships is always LinkedIn. You guys can
Okay.
just search about IoT workshops, or I'm sorry, IoT internships, and LinkedIn is a platform where you can get much better opportunities than these other different platforms that like Naukri.com or other stuff. So I haven't tried any of these websites, but yeah, LinkedIn is much better than these.
One more thing was, what are the things that are expected from an internee of IIT, sir?
Okay, so
From an intern.
good question again. So, as in, see, that totally depends on which side you are applying. If you are applying to the cloud side, or basically, I would say that if you want to join as an IoT intern, what we are expecting is device knowledge, basically, how these devices interact with the cloud, and if you have some, experience with Android development. So Flutter, if you can do, is a much better option, I would say, because Flutter is something that you can use to make dashboards as well as the mobile application, and it is a cross-platform mobile app development thing. So you can develop this Android app as well. You can develop a web app as well. You can develop a iOS app as well. So if you put yourself a little bit into the Flutter side, it's always good to have that knowledge as well. And one more thing, if you guys have worked on any of the IoT platforms, like Amazon is providing AWS IoT, and Microsoft is providing Azure IoT, and there is Google IoT. So I'll really recommend if you guys can work on these platforms.
Okay, sir. Thank you so much, sir.
Yeah, thanks. Okay, so I am trying to join through my iPad as well, but I'm not able to join. Can you guys can let me in? Uh, I have requested to join the meeting. Will you please let me in?
So you need not make a request today because we have opened it for all to join in and bypass the
Okay,
lobby.
okay. Then
Yes, sir.
just a second. Uh,
So are you still not able to join in?
okay, it's connecting, but I'm not able to join. Okay, it's there.
Okay, so fine. So shall we start with the session then?
Yeah, sure. Just a second.
Okay, sir, sure.
Okay, so a very good afternoon, everybody, and a warm welcome to day two of this IoT workshop. Before jumping into the session, I would like to take this opportunity to welcome you all to day two of this IoT workshop. First and foremost, I would like to welcome our respected speaker, Mr. Shrey Sharma, who's director at SmartDen Innovations, who is making our IoT journey more fun and easy. Warm welcome to you, sir.
Thanks a lot. Thanks a lot, Mudad.
Next, I would like to welcome all the dear participants for joining us today for this interactive session. A very welcome to all of you guys also.
Thank you.
I hope you all got learned a lot yesterday. In today's session, you'll be learning about MQTT Protocol communication models of in IoT, communication ESP12 to Wi-Fi, introduction to SmartDen.Tech, and along with that, important libraries of ESP12. Am I clear with this?
Yeah.
Yeah. The overall session flow will be like this, that we'll be starting with the talk, and after that the flow would be open to the questions. You can have some other questions in the chat box anytime during the session, which will be taken in at the end, and that question and answer will be taken at the end. So now I like to make this program to get started off, and I hope again that you'll be all be learning it again with a lot of joy and having learning, please. And over to you, sir. Please continue with the session, sir.
Yeah, thanks a lot, Mudad. Okay, so I'm sharing the screen, so please let me know if it is visible to you guys. Just a second. Okay, I guess it is visible.
Yes, sir, it's visible to us. It's visible
It's
to us.
visible, sir.
Okay, perfect. So what we have on the screen is our platform, which is SmartDen.tech. Okay, so I'll introduce you to the platform a little bit later. Let's start with the basic Arduino. So here I have the most simplest Arduino program. So first I'll introduce what exactly is an Arduino, and then for the first year students, how to get started with the Arduino and what you can do with this Arduino basically. So Arduino is a microcontroller, and it is more of a development board to test your prototypes, how the things work, how the microcontrollers work, and you can design products out of it. So I myself started with Arduino, and then I shifted to ESP12, and from there I built a product. Now we are shifting to ESP32, which is a upper version of ESP12, and our products are based on that microcontroller. So it's the starting journey of developing prototypes and then converting those prototypes into the products. So basically, if I let me quickly turn on the camera so you guys can see that thing as well. Okay. I hope this Arduino board is visible.
Yes, it's
Yes,
visible,
sir.
sir.
Yes,
Visible.
sir.
So this is the Arduino board. If you guys are wondering what am I saying, so this is this particular microcontroller board. It is the Arduino board basically, and if you can see one yellow light is blinking there.
Yes, exactly, sir. It's
Yes,
visible to
sir.
us.
Yeah. So this is the Arduino board, and I have connected this Arduino board to the computer, and this the software that we are having here on the screen is called the Arduino IDE, which is the development environment for the Arduino. Here we write our codes, and then we upload these codes onto the Arduino, and the Arduino will perform functions accordingly. So in this Arduino IDE, we don't call the complete coding. We don't call it a program. We call it a sketch. So whatever program that you will be building in this Arduino, it's called the sketch for an Arduino. And all the sketch have, okay, let me show you how it looks. When you click on new, it will look like this: void setup and void loop. So void setup and void loop, these are the two functions that you must include in your Arduino sketch. So first of all, we have a program which we call sketch in terms of Arduino IDE. We upload a sketch to the Arduino board so that the Arduino can perform operations according to our commands. I hope it is clear to everyone.
Yes, sir.
Yes, sir.
Perfect. So as you can see, there are two functions. One is void setup and second one is void loop. So whatever we define between these blocks, whatever I will define here is in the setup part, and whatever I will define here will be considered in the loop part. So now, why do I need a setup and why do I need a loop? So setup part is basically you are telling the Arduino that I want to use these operations one time. I am just setting up the Arduino board. I am just writing the commands that needs to be executed when the Arduino turns up. Okay. So these are the commands, whatever the lines I will write here between this 1 and 7, whatever the lines I will write here, they will be executed when the Arduino is booted up. So it is only one time execution, and once you define, it will be defined for the rest of the program for the time till the Arduino is powered on. So you need to define all those things that you want to define only one time in the Arduino sketch, and the Arduino will perform accordingly. Now in the loop part, the Arduino will process all the data, or whatever the lines that you write here, whatever the code that you will write here, it will just repeat it again and again. So Arduino will just call this function loop again and again infinite times. So you have to be very careful what you are writing here, because that will be repeated again and again. So let's come to our example. So that is the basic example. So here the first line that I've written is pin mode, then 13, then output. So a pin mode is basically defining the pin of Arduino that I want to use this particular pin as input or output. So this is the function pin mode, and it has two arguments. First one is the pin number, and second one is the how you want to use it. Either it has to be an input pin or it has to be an output pin. So each and everything in the Arduino is defined on pins. So you either be, you can only just use the Arduino for the pins. Whatever the operations that you want to perform, it has to be on the pins itself. Either you want to turn on a LED, it has to be connected to some of the pins. Either you want to sense the data from some kind of sensor, it has to be connected on a pin. So each and everything will be performed through these pins. Okay, so it's better if I can just a second. Are you guys able to see this image? The image of Arduino?
Yes, sir.
So as you can see,
Yes,
we
sir.
have 0 to 13 pins, and then we have G and D, that is ground. Are you guys able to see it?
Yes, sir.
Yes, sir.
Yeah.
Yeah. Can you please mute yourself, whoever is there? Okay, thanks. So we have some digital pins. Then on the opposite side, we have analog pins A0, A1, A2, A3, A4, A5. These are the analog pins. Then we have power pins. V in as in voltage input. Then we have two ground pins. Then we have one 5-volt pin, one 3.3-volt pin, then reset pin and input output reference. Now this is the IC, this is the complete brain microcontroller IC at Mega 328P. This is the IC and all the pins are connected to this particular IC. We power up the Arduino with a 12-volt adapter. The basic power supply, or the power supply that we need to give to Arduino, is a 5-volt power supply, but we have some internal converter IC. Here we have IEEE 1175 IC, which will convert your 12 volts to 5 volts, or you can directly supply 5 volt to this pin. So this is the working voltage or operating voltage of Arduino. Here we have this port, which is a USB A to B port, and you can connect it to the computer via the cable, USB A to B cable. Now we need to access these pins 0, 1, 2, 3, 4, 5, 6 up to 13. So these are the digital, or we can say the GPIO pins. GPIO stands for general purpose input output. So we have these pins for all the operations that we want to perform on the Arduino board. Then you can see a tilt icon or a tilt mark over 3, 5, 6, 9, 10, 11, these pins. Are you guys able to see that?
Yes, sir.
Yes, sir.
Can you zoom out the picture?
Zooming that in just a second. Are you guys
Sir, you
able
can
to see it now?
mute.
Are you guys able to see it?
Yes, sir, it's visible.
Okay.
Yes, sir.
So from 0 to 13, we have digital GPIO pins, that is general purpose input and output pins. And on the pin number 3, 5, 6, 9, 10, 11, we have
Yes, sir. Continue.
PWM pins.
Yes, sir.
So that stands for pulse width modulation. Uh, Whoever is there, please mute yourself. If you have a questions only, then you can please unmute. Okay, so these digital pins are used to perform digital operations, and when I say digital, that means 0 or 1. Either it has to be 0 or it has to be 1. If it is 0, that means 0 volt, and if it is 1, that means 5 volt. So if I am using, let's say, pin number 13, so there is this LED L. L is written here, which means LED. This LED is connected on the pin number 13 for debugging purposes. So if I'm using the pin mode and 13 as an output on my sketch, so if I go back to the sketch, I'll show here I've written pin mode 13 and output, which means I'm using the pin number 13th of Arduino as an output pin. So whatever I'll be doing, I'll be considering that I have to send some signal on the pin number 13. It will act as an output. It will generate an output of either 0 volt or 5 volt. So it's always about the voltage. Now coming back to the Arduino image, we have this tilted icons. So these are the PWM pins, which means pulse width modulation. We can modulate the pulse through these pins. We can vary the voltage between 0 to 5 volts. As similarly, if we want to read something between 0 to 5 volts, we use analog pins. Analog pins are for the sensors, or I should say the analog sensors, which are providing the voltages between 0 to 5. Digital is for 0 and 5. PWM pins are for generating a pulse from 0 to 5. Analog pins are used to read the voltages that are from 0 to 5. I hope everything is clear. Any doubts?
Yes. No, sir.
Perfect. So this is the basic pin diagram of Arduino, and now let's go back to our sketch. I'll not use this line yet. Yeah. Do you have any question?
So you told that in the pulse width modulation, it will vary between 0 to 5, as
0
well
to
as
5.
in the analog also you told it will vary between 0 to 5.
Pulse, yeah.
So how is it? Yes.
Yeah, please complete your question. Yeah.
Yes, sir. So how is it different? Like in PWM, will it be having a modulation in the bandwidth or something like?
I'll tell you. So PWM pin is for output pins. PWM pins cannot read the signal between 0 to 5. PWM pins will only generate a signal from 0 to 5 volts. Analog pins will read any signal from 0 to 5 volts. I hope you got the
Yes, sir.
difference.
Yes, I got it.
Yeah.
Thank you, sir.
So here in the setup part, I have written that I want to use the pin number 13 of Arduino as an output pin. That's it. So this is the overall statement I have written here in the setup part, so that Arduino will define this thing one time and it will maintain throughout the program. So it's you can consider it like the global variable that you use in C, C++ or any programming language. So I've defined that I'm using pin number 13 as an output, and pin mode is the function. And you have to be very sure while you are writing any code in Arduino, because it is a case sensitive. You can see that it is orange as of now, but if I use small m, it will turn black, which doesn't donate any function. So I have to use it like this only. I hope the setup part is clear to everyone.
Yes.
Yes, sir.
Perfect. Now going to the loop part. So these are the comments. You can write the comments with double backslash. Put your main code here to run repeatedly. So I'll use this code to blink the LED. So here I have written digital write pin number 13 and high. So I have defined that I want to write a signal. I want to write high value, or I want to write 1. So either I can use high or I can use 1. I'm writing here digital write, and on which pin I want to write this high or low value. I'm sending this signal to 13th pin. So it says digital write 13th and high, which means turn on the 13th number pin or supply 5 volt to the pin number 13th. So this will basically turn on the LED. There is an LED on pin number 13. So this command will turn on the LED on pin number 13. Or you can consider it applying 5 volts to pin 13. Now here we have a delay. So this will pause whatever the Arduino is performing. So if the compiler will go to this line, it will take a pause. And for how many milliseconds? We have to define the milliseconds here. So 1000 milliseconds, I guess 1 second is there. So it will take a 1 second pause, and then it will jump to the 9th line. And on the 9th line, I have written digital write 13 low, which will turn off the LED, or it will supply 0 volts to the pin number 13. And again, there is a delay of 1000 milliseconds. I hope it is clear.
Yes,
So
sir.
for that 1 second, will the Arduino be on or in some other state?
Arduino
When will
is always on. Arduino will be on, but at this point, it has a command that it has to wait for 1 second, so it will not perform any operation. It will not jump to this line. It will
okay,
be
so
stuck
the
here.
LED, so the
LED will
LED
be
will
LED
be
will be on. LED will be on because we have
okay.
performed this operation. LED is on, and then we have told Arduino to wait. So it will wait
Okay.
for 1 second, and then it will execute this line. Then it says LED is off, and then it will again wait. Until that time, the LED will be off, and then it will go to the loop again. It will turn it on again. So again, let me turn on the camera and I'll show it to you. You guys can see there is a 1 second gap, and the LED glows, and then it turns off.
Yes, sir.
Right?
Yes.
Okay. So now let's see how to upload the sketch to the Arduino board. Now, if you see on the top, you have these options: file, edit, sketch, tools, and help. You need to click on the tools. You need to go to the boards. By default, if you install the Arduino IDE for the first time, you will not get these options. ESP32, ESP8266, XTM, you will not get these options. You'll only get Arduino AVR boards, and then from there you need to select the Arduino Uno. So this is the process that you need to do to upload the sketch on your Arduino board. So this is basically selecting a board on which you want to upload your sketch. With the Arduino IDE, you can program these multiple boards. So these are the ESP32 based boards. These are the ESP8266 based boards, and these are the STM32 based boards. So you can program these all boards with this Arduino IDE. Currently we are just using Arduino board, and let's select the Arduino Uno, and then I need to click on the upload button. Again, I have to select the port as well. Once you select the board, then you need to go and select the port. Here I have connected Arduino on COM port 4. I need to click on that and it will select the COM port, and then I have to click on this arrow which is upload. Now if you look down, you will find this bar. So it's basically compiling the sketch, and after the compiling is done, it will upload. And if there is any error, you will see it here. It says can't set COM state for board COM port 4. Okay, so if your serial monitor is open, you can't upload the code. Let me reconnect it. You'll get a lot of errors if you are working with Arduino and these things. It can be due to multiple reasons. So you have to disconnect and connect it multiple times. So this is your debug section where you can see what's wrong with the program, and it says done uploading, and the program is uploaded. But you cannot just see what is happening. You can only see the visuals. If you have programmed the LED, you can see if the LED is blinking, then the code is successfully programmed. But now let's come to the part where we need to debug our sketch, how to print the debug information onto the screen so that we can know what exactly is happening on the Arduino board. So for that we use a serial function which is called serial.begin. So first we need to define the baud rate. Okay, here's a question for electronics students, especially for third year students. Can anyone tell me what is a baud rate? BAUD RATE, baud rate.
Number of bytes transferred per second.
Exactly. So basically it's the data transfer rate. So we have to define the baud rate while we are programming for Arduino. So on the setup part, we need to define serial.begin. So that means we are using the serial monitor, and we need to define the baud rate on which speed we are using it. Then we can use serial print commands. And here I'll write in double quotes, LED is on, and a semicolon to terminate. After the LED is off, I need to write LED is off, and let's upload this sketch and see what happens. Okay, it says uploading, done uploading. And here if you see on the top right, we have a serial monitor, and you can see the data is coming. LED is on, LED is off. After every 1 second, LED is on, LED is off. So here's how you can debug whatever you are performing on the serial monitor.
Sir, I have a question.
Yeah, please.
Sir, in the while loop, you have written for 1 second on and 1 second off.
Yeah.
Can we use the program multiple times that delay 1000 and again delay 2000, delay 3000, like that we can write, no, sir?
Yeah.
So the LED series
Yeah.
1 turn off, 2 second turn off, like that.
What exactly do you want to achieve? Tell me that basically.
So for
You want
example,
to
time the LED is on for 1 second.
10
Again,
LEDs. 10 LEDs or one LED for 10 seconds?
no, sir, not like that. First, we have written digital rate 13 high for one again 1 second. It's for only 1 second.
Right.
So in that program only we can write again 2000, 3000 delay time.
Or you can simply write 10,000 here and upload it. Your LED will be on for 10 seconds.
Sir,
Why?
again 12th line we can write delay 2000, like that.
Yes, you can write any kind of delay. So it will just pause the program for that time. So let me clear this serial monitor and again let me restart it. So I've restart this board and you can see LED is on. It's written here. I've used the delay for 10 seconds and you can see 13:38:43 LED is on. 13:38:53 LED is off and again after 1 second it is on. Now it will turn off after 10 seconds. You can write multiple delays as well, but there's no point. It's like adding again if I add, let's say, delay 2000 here, so it's no sense of using two times here, because the total weight will be 10,000 plus 2,000 is 12,000. Either I'll write just 12,000 here. So yeah, what's the point of using multiple delays? I hope it's clear.
Yes, sir.
Yes, sir.
Thank you, sir.
So this is
Sir,
how.
can you
Yeah, please go ahead.
explain a little more about serial dot begin statement, sir?
So as we have defined the pin mode as 13 and output, and we are using it as output, similarly we are using the serial monitor and we are using the serial dot begin just to begin the serial monitor at this baud rate. So this is our serial monitor. Okay, let me show you. So we are telling the serial monitor that we are using the serial commands on this baud rate and we have to set the serial monitor accordingly. If you go down, you will see this one 115200. This is the baud rate. This is the baud rate for serial monitor, and this that we have defined in our setup part, this is the baud rate for the Arduino, and it has to match with the serial monitor on the Arduino IDE. If I change this serial monitor to, let's say, this figure, I will not get the data properly. I'll get the garbage value, as you can see here. This is the garbage value. So I
Okay,
have to
sir.
make sure that each and every baud rate that I define here, it has to be same with the serial monitor's baud rate. If it is same, then only I'll get the exact data. You can see like LED is on. So you need to pretty sure about what kind of baud rate you are using. If I change the baud rate here to 9600, and if I upload this sketch again, now let's clear the serial monitor, and here I have again defined 115200 as the baud rate, and as you can see I'm not getting any data. Even if I restart the Arduino, I'll not get any data. The baud rate has to be same 9600. Now you get the data. So that's the concept of using baud rate. I hope it's
Got it,
clear
sir.
to everyone.
Yes, sir. Thank you, sir.
These are the things that we use for debugging purpose. Now let me check what I can. Okay, let's start with this. So I've created a few programs for you guys and I'll share it with you so that you guys can tinker upon these things and you guys can have a look of what different things you can perform with Arduino. So I'll share all these sketches with you. Just a second, let's let it open. So this is the SmartDen.tech. Okay, it's open. By the way, I'm showing this. This is the SmartDen.tech program that we will provide you, and you can use this program. I'll show you what kind of changes that you need to make. And with this program, you can directly access this particular dashboard. You can create multiple devices here. So we'll check that in a bit. Okay, so here is the program, and let's go through it and let's see what it does. So here I have defined a variable constant integer type prox sensor on D2. So basically this is designed for node MCU, or we can say ESP12, because in Arduino we have pin number 0 to 13. In node MCU we have pin number D0 to D8, D0, D1, D2, D3, D4, D5, D6, D7, D8. So this is the program that I've defined for I've made for node MCU, but you can either use it in this Arduino as well. I'll just clear it. Okay. Okay, let's start. So here I have defined pin mode 13 as output, which means again I'm using the pin number 13th of Arduino as output pin, and here I have defined pin mode, and here I have written a prox sensor, which is not a pin but it is a variable. So I have to define here a pin by the name of prox sensor. Let's make it clear and let's say PIR sensor. Do you guys know what is a PIR sensor?
Yes, sir.
So for
Proximity
those who don't
Passive
know,
detection.
infrared sensor.
yeah, it's a passive infrared sensor, or in layman language we can call it as a motion sensor. So it will detect the motion. So here I have
Okay.
connected, here I have used pin mode, PIR sensor and input. Now here I haven't defined any pin number because I can directly define here as PIR sensor as a constant integer and the pin number will be 2. So in that case, the sensor that I will be connecting on the Arduino's pin number 2 will be considered as a PIR sensor, and it is connected as an input pin. So either I can read the value 0 from that sensor, or either I can read 5 volt or 1 from that sensor. Either 0 volt or 0, or 5 volt or 1. So there are only two voltage levels, 0 or 5. So pin 2 is connected to the, okay, let's remove this comment. So we have used PIR sensor on pin 2 of Arduino. Okay, again serial.begin, which means we have started the serial monitor on 9600 baud rate. In the loop part, it's a simple if and else statement. So first we are using this statement if digital read. Previously we have used the digital write function. Here we have used digital read if digital read PIR sensor. That means the Arduino will read the value from this PIR sensor, and if it is high, equals means we are comparing it. We are comparing the value that we are getting from this function, and we are checking if it is high or low. So here with the help of digital read function, we are getting the value of PIR sensor. We are comparing it with high or low. If it is high, then turn on the LED. We are writing digital write 13 comma high, which means we are writing high voltage or 5 volts to the pin number 13th of Arduino. So that means if digital read PIR sensor is high, that means any motion is detected, it will turn on the LED. Else digital write 13 low. So the by default, if there is no motion, the LED will be off. You guys can, okay, so this basically input value, let's define this input val. So I've defined another variable which is input val, which is of integer data type. So it will store all the information that we got from this function digital read, and it will just print the data here, and there we have a delay of 1 second. So I haven't connected any sensors, but let's see what the program gives us as output. Let's compile the program. Okay, I forgot the semicolon here again. It is compiling. Let's see how it goes. Are you guys able to understand this Arduino coding?
Yes, sir.
Yes,
Yes,
sir.
sir.
Great.
So I had just one doubt.
Yeah,
Sir,
sure.
what's that? That's the what's the meaning of that serial dot begin 9600?
Serial.begin is again, it's a it's a command for serial monitor. Okay, sorry, I'll ask you, I'll answer this question, but first we have an error. Let's check.
Okay, okay, no problem.
It says serial dot this could not open COM port 3. So that means I have something wrong with my COM port, and then again I need to go to the tools, and you can see that I have selected board as node MCU, which is an ESP8266 board. Now here I need to select Arduino Uno as the board, and I had to select its actual COM port. So these are the things that you need to take care always while uploading the sketch in Arduino. Now coming to the serial.begin. So serial begin is used, this command is used to set the baud rate of Arduino, because every machine has its baud rate if it is connecting to a laptop or any system, because when there is a data transmission you have to define the speed of the data transmission. So with this serial.begin we are defining the baud rate of Arduino, the hardware I'm talking about, and if I click on here I am defining the baud rate of Arduino IDE. So let's set to 9600. So here as you can see I'm getting 1 1 1 0 0 1. So these are the values that I'm getting, and it is just using this command on that is on the line number 21, because I have written serial.print and input value. So whatever the pin, whatever is there on pin number 2, we are reading it and we are storing it in input val, and then we are just printing whatever is there after 1 second. So these are the values that I'm getting. So serial.begin is basically just to define the baud rate of Arduino. It has to be either 9600 or 1115200. And we have to match that baud rate with this serial monitor's baud rate. Okay, so this is like the basic stuff of Arduino. The more you practice, the more you'll get to know about it. Now coming to the ESP12 microcontroller. What exactly is the ESP12 microcontroller? I'm just okay. Let me do one thing.
So,
Yeah,
int here signifies that it is of data type integer. What does this constant signify then?
constant means you once you have defined it as 2, it will not change throughout the program. It is 2 only. And because we have defined it constant, because we are defining it as a pin number, and we are not defining it as some integer or float value. And pin has to be constant. You cannot change the pin number again and again, because if I don't use any constant here, and see integer, we are using integer in the loop part here, right? It's in the loop part. But whatever I define here as the pin number, I have to use it in the setup part, and setup part will only be called when the Arduino is starting. So once all the things are defined here, it will not change. So that's the reason we need to define it as constant. Okay. I'm turning on the camera again. So I'll show you what exactly ESP12 looks like. So you can see this is the ESP12. This is a smaller microcontroller. Again, it has pins here. You can see these are the pins. This is the main chip, ESP12 chip, and this complete thing is called the development board, ESP or the Node MCU development board. So it is also written here, Node MCU.
Yes, sir, you're not visible, so I don't know whether it's only for me or for everyone, sir.
Am I?
No, even me.
Not on.
No, sir, it's not
Even me, sir,
visible,
I
sir.
can't see.
So I
Yes,
think
sir,
your
not
camera has not
visible.
been turned on right now also.
Okay, let me quickly turn off the camera and I'll quickly turn it on again. Are you guys able to see me again?
No, sir.
No, sir.
Sir.
No,
Still
sir.
no.
No, sir, no, sir.
No, sir.
Uh, okay. Just a second. Just a second. Are you guys able to see me?
Yes,
Yes,
sir.
sir. Now you are visible.
Okay. So are you guys able to see this microcontroller?
Yes, sir.
So
So
this is
actually, I
the
think because of a background, I think there is something blurriness that is going happening in trend.
okay. Let me just turn off the camera and I'll share the screen again and then I'll show it to you on browser itself. Are you guys able to hear me?
Yes,
Yes,
sir.
sir.
Yes, sir.
So actually, your camera was visible to us. I mean,
Hello.
whatever we think that you
Am
were
I
showing to us,
audible?
it was visible to us, sir. But actually, in between, some of the things were getting mixed up.
Delay is happening, sir.
Hello. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir, yes, sir.
There is a connection issue. Let me just try to connect it again through my laptop. Just a second. Okay, how many of you guys have these development boards at your place? How many of you have Arduinos and ESP12s?
Sir, I have an Arduino Uno board, sir.
Okay, two, three.
Yes,
Okay, you guys
yes,
can raise the
Arduino.
hands. You guys can raise the hands. Whoever has Arduino board or ESP, or sorry, ESP12 Node MCU, please raise your hand so that I can know. We have around 190 people here, and let's see if you guys have. Okay, 8, 9. Great. Okay. So only 9 to 10 people are aware of these things. Okay.
Excuse me, sir.
Yeah, please.
I don't have an Arduino, but there's a dashboard called Tinkercad which I use to design.
Hello.
Hello. Yes, sir.
So you are aware about these microcontrollers and other stuff, right?
Yes,
Okay.
sir. Like virtually, I use that Tinkercad dashboard to design, sir.
Okay. Perfect. 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 Okay. So please let me know if the screen is visible again.
Yes, sir. It's visible.
Yes, sir.
Yes, sir, it's visible.
Okay. Let me search for an HD image if I can find one. Okay, so are you guys able to see this image?
Yes,
Yes,
sir.
sir.
Is it
Yes, sir.
visible?
Yes, sir.
Visible, sir. Yeah. So basically, this is your ESP8266 ESP12 board. So these are the pins and these are the functions that they are performing. So here, as you can see from the top, we have D0, D1, D2, D3 up to D8, and then we have RX and TX. So I told you that these are the UART, RX and TX pins, and they are available on each and every microcontroller. So GPIO, sorry, in Arduino we have GPIO 0, 1, 2 up to 13, and here we have D0 to D8 and the corresponding GPIO number. So pin number is different, GPIO number is different. GPIO, that means general purpose input output. So D0 is called GPIO 16, D1 is called GPIO 5, D2 is called GPIO 4, D3 is GPIO 0, D4 is GPIO 2. So that's the naming schema here, and different pins, different purposes. So this MOSICS, MISO, SCLK says clock, and master in slave out control signal, M master out slave in. These are for I2C communications. So as I've told you in the previous session that there are multiple interfacing protocols. RX and TX are for UART. These are for SPI I2C pins. So again, different pins, different purposes. So let's not go into that part because that is a little lengthy session. So again, the overall idea is to get familiar with this board, and we will be using these digital pins only. So this is your node MCU, and we will see how we can program it with the Arduino. But let's focus on the MQTT protocol first. A little bit theory again, but it is important, I guess. That's why we need to discuss it. Okay, I'm sharing the screen again, but this time on iPad. Is it visible?
Yes, sir.
Okay, so let's quickly take a look at MQTT protocol, and then we will jump to the ESP12 again. Okay, why is this thing happening? I'm sorry, I need to just erase this thing. Okay. MQTT stands for Message Queuing Telemetry Transport. So this is a protocol for IoT. Remember in the previous class I've told that we have a device, we have a medium which is a Wi-Fi or a gateway, and then we have the cloud. Now this MQTT protocol, it falls here because we need to transfer the data from this device to the cloud. Now there has to be some kind of rules, some set of rules that we need to follow. Just a second, I'm sorry for this. I don't know why it is happening.
Sir, I guess for low charge.
Charge is low, that but there is this bar that is again coming again and again. Okay, I guess it's sorted now. Here is your device. You need to connect it to the cloud. You have to follow some kind of protocol, some set of rules, and here comes the MQTT, which is the way you transfer the data to the cloud. Now in the MQTT we have a server which is called the MQTT server, and we call it broker. So this is a cloud server, or it can be on your device or on your Raspberry Pi as well. So each and every communication happens through this MQTT broker, and all the devices are the endpoints that are connected to this broker. And to access this MQTT broker, first you need to have an IP of this broker, then you need to have a port number of this broker, and if you want to make it secure, then you also need the username for this broker and a password. If you have these four things, then you can access this MQTT broker, and then you can connect multiple devices, and you can have a communication with each other. Now let's say the IP for this is 192.168.4.1, that is the local IP of ESP, or any IP or any third-party server IP. You can just consider it as an IP address. The default port number for this is 1883. The username can be anything, or the password can be anything. So if I have these four details, I can connect my device, my IoT device, to this particular MQTT server, which we call the MQTT broker. Now we will take the example. So there are few terminologies in MQTT. We will study them one by one. So I'll write it down here. What are the things that we need to study? First one is topic. Second one is pub or sub, which is publish or subscribe. Third one is client ID. So these are the basic things that we need to study. Then we have QoS, which is the quality of service. So let's say, okay, one more thing, which is the payload. So let's say I have a mobile device. Mobile device will also act as a client. So here I have a mobile device, and let's say it is a home automation app. So it is a mobile app. So it will also act as a client, and here I have few buttons. This is, let's say, for LED. This is for bulb, and this is for fan. Let's say I have this mobile application to turn on and turn off three different appliances: LED, bulb, and fan. And here I have a smart switchboard where I have three switches. First one is for LED, second one is for bulb, third one is for fan. So this mobile application controls these three different switches. One switch is connected to LED, second one is for bulb, and third one is for fan. So these are the two clients for this MQTT broker. And whenever we connect anything, either it be a mobile application or a dashboard or any device, it is considered as a client. So this mobile app will also have a client ID, let's say 01, and this switchboard, or I'll say smart switchboard, this will also have a client ID, and let's say 02. No two clients can have the same client ID and can be connected to the same broker. If they have the same client ID, the connection will not establish. So the client ID has to be unique for all the clients that are connected to MQTT broker. Now I want to transfer the data from this mobile app to this switchboard because I want to perform the operation on the switchboard itself. So I have to transfer the data to this broker, and then this broker will transfer the data to this switchboard. Now how it is happening? So client ID, you guys have understood that, okay, it is a specific identifier for any client that is connected to the MQTT server. Now let's come to the topic, publish and subscribe part. I'm creating a little table here. Let me know if you guys are able to understand it. So just to simplify the things, whatever application or whatever the mobile app or any website that you use, every button that you click has some action associated with it, right? So here we have three different buttons, LED, bulb and fan. And to turn on the button, there has to be some kind of command that is associated with that button. So whenever you press the button, that command is triggered, the data is sent and the action is executed, right? So to turn on the LED, let's say I will send A, and to turn off, I will send B. To turn on the bulb, I will send C, and to turn it off, I will send D, and similarly for fan, E and F. I hope it is clear.
Yes, sir.
So this is basically, these are called the payloads. So this is the data that is associated with each button. Okay, I guess payload is clear. Payload is the data that you are sending over the MQTT. Okay. So here we have the payload as A, C, E to turn on LED, bulb and fan, and B, D, F to turn on the turn off the LED, bulb and fan. I hope you are getting it.
Yes, sir.
Yes, sir.
Okay, so now we need to understand how the things are happening, how this data is transferred from this mobile app to this switchboard. So let's focus on topic. Let's try to understand that I've created a pipeline here and I've created another pipeline here. So topics are generated runtime. So whenever you connect any device to the MQTT broker, a topic you can generate on runtime. But if you want to transfer the data between two devices, their topic has to be same. So basically you can consider the topic as a pipeline. So if I define the topic as test here, and if I define the topic test here, only then the data or the payload will be transferred from here to here. Is it clear?
Yes, sir.
Sir, a topic, then it is a command, sir.
Yes, yes. A topic is basically, you can consider it as a pipeline. So
pipeline in sense,
because you have to, yeah. So let's introduce publish and subscribe, then you will get to understand the topics better. Now if you see, you only focus on these arrows. This is upward arrow, that means the mobile application is sending something, that means it is publishing something. So it is publishing A on topic test. Okay, now this device, this smart switchboard, it has subscribed. It has subscribed on the topic test to receive the commands that are published on the same topic. So the mobile application is publishing the data on test topic, and the switchboard has subscribed to the test topic to receive all the data. Did you guys understand the functions of topic, publish and subscribe? Okay, let's make it very clear with another example. Let's say there are two friends that are in a classroom and they can communicate only via the pipes, and there are multiple pipes between them. What will be the condition in which they can communicate? Let's say if this is A and this is B, if A picks the pipe number 3 and B picks the pipe number 2, will they communicate? Will they be able to communicate?
No, sir.
No, sir.
No.
Exactly. So that is why I'm relating topic to a pipeline, because both of them needs to have a single or same pipeline. If they are if A is picking the pipeline number 4, then B also has to pick the pipeline number 4 so they can communicate. Now, if A wants to say something to B, what will be the condition? A will publish the data on 4 number pipeline and B has to subscribe on the 4th number pipeline. It's like A will be publishing and B has to put ear on it. That means A will be speaking and B is listening. So this will be the publishing and subscribing will be the listening. I hope it is clear now.
So is topic a kind of communication channel, like common communication channel?
Yes, absolutely. It's kind of a common communication channel which is generated runtime. And if I use let's say if I differentiate by just adding 1, if it is written here test 1 instead of test, and I'm publishing the data on test, no matter this test 1 will receive anything. It will not receive a single data that is published on test. So it has to be same. Only then the MQTT communication will happen.
Sir,
Mm-hmm.
if two clients are publishing on same topic using
Yes.
same pipeline, then will both the messages will be received by the subscribed client?
Yes, obviously. Let's say if I'm sorry for my drawing, but yeah, that's the easy way, I guess, to tell you guys. Okay, let me just. It's more of a situation here. I'll explain how it works. So it's something like this. So it is publishing, it is also publishing, but it is subscribing. So whatever the data that is transferred from here and here, it will listen both of them. I hope it is clear.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Then there is no way of authentication, sir. Which device, like
Authentication? No, there is no authentication, but there is one thing that you can do, which is called, again a deeper concept of MQTT, which is called ACL, which is called access control list in MQTT, in which you can restrict the user to listen to a specific topic. Let's say if I am restricting this user to listen to test 1 topic, it will only listen to test 1. It will not be able to subscribe multiple topics. So ACL is a concept which is again a deeper concept. You guys have to study a bit about it. But overall, this is the process, basically how the MQTT communicates and how we will be communicating with our mobile application in SmartDen.tech as well. I hope it is clear to everyone.
Excuse me,
Also,
sir.
one thing.
Yeah, please.
Sir, if one subscriber is subscribed to two different publishers and they are giving different contrary commands, then how will that subscriber act? The way one is saying on and the other one is saying off. Then what will that subscriber do?
No. Okay. Okay. So let's say again a gypsy drawing. I'm not sure if you guys are able to understand Hindi as well. Uh, since you are
No, sir,
from
we can
India.
understand it,
We
sir.
can understand, sir.
We can understand it, sir.
Okay.
Yes,
Okay.
sir.
Perfect.
Yes, sir.
हाँ तो ये
Yes.
थोड़ी अजीब सी ड्राइंग सहन करनी पड़ेगी तुम लोग को हाँ
कोई बात नहीं सर.
okay so you were saying that this guy has subscribed to let's say multiple topics and this one is saying on and this one is saying off. Now you are only listening to it, you are not performing any action. There are two different things. You will also receive on, you will also receive off, but you are not performing any actions on and you are not performing any actions on off itself. It's totally depends on you on which command you want to perform action. There is a you know variable, let's say there's a string type variable payload and you are storing the data in payload. So if you print serial dot print this payload, you will get on, off, 1 2 3 whatever is there coming from these two topics, but you haven't performed any action, you are just printing it. Are you able to understand what I'm trying to say? You will get the data but you are not performing
Yes,
any
sir.
actions. You will only perform any action only if you are using any digital read digital write command, or if you are performing, let's say if I'm comparing, we will use this thing as well. If payload is equals on, so once I receive on, I have to write 13 as high. So that means if whenever I receive on, I will do this thing. Also you can compare topics. Let's say this is the test and this is test 2, this is test 1 and test 2. You can also check if the topic is equals test 1, so that only if this a b and c, only if this a person is sending data over the test 1 topic and if it is on, then only you can perform the command. So that's totally depending upon your programming skills, how you want to compare things. So here I am comparing, if the topic is equals test 1, then I will execute this block of code, and again if the payload is equals on, then I'll execute this code. So until or unless my topic is not equals to test 1, I will accept this thing. The compiler will go directly to this line, it will not enter this block. I hope it is clear now.
Yes, sir. So basically, it kind of works as a filter.
Yes, obviously you have to create a filter, obviously, because you cannot restrict the data that is coming to you. Once you have subscribed, it's like कि आपने बोला कि हाँ मेरे को ये सब चीज सुननी भी है और मेरे को फिर नहीं भी सुननी, तो दोनों चीज नहीं होंगी. So if you have subscribed to a topic, then you will listen anything that is coming from that topic. It's only up to you if you want to perform the action accordingly. Got it?
Yes, sir.
Yes, sir.
Okay. Any other doubts? I guess this MQTT is cleared. This one quality of service is there. There are three quality of services that you use in MQTT: 0, 1, and 2. Quality of service 0 means that I have transferred the message from here to here. It doesn't matter if it is received or not. My job is to transfer it. That's it. Quality of service 1 is I will transfer the message and I will make sure that it receives, and I'll not make sure that it will perform any operation on it. Quality of service 2 means both the parties must have acknowledgement that the message is delivered properly. So it's basically quality of service, how the message is delivered from one end to another end. In Node MCU, we are only restricted to quality of service 0 and 1. Mostly we use 0. because it is supported by this library that we will be using to create a connection, MQTT connection. I hope it is clear.
Yes, sir.
Yes, sir.
Okay,
Yes,
then
sir.
let's get back to our programming part. Okay, just let me share the screen again. Okay, is it visible?
One doubt, sir.
Yeah, please go ahead.
Sir, what is the meaning of 012 in quality of service?
Quality of service 0 means that you have delivered the message and you don't know whether the receiver have received it or not.
Yes, sir.
Quality of service 1 is somewhat like you have an acknowledgement that message is delivered.
Yes, sir.
Quality of 0, you have just transferred the message, you don't even know that if it is delivered or not.
Yes, sir.
Quality of service 1 is about like you have transferred the message and it is delivered. Quality of service 2 is somewhat around you have transferred the message, it is delivered, and the client has also acknowledged the message that it is received properly, and the function that is needs to perform, it has performed, execute accordingly.
Okay, sir. Thank you.
Yeah. Okay, so now we will see how to program ESP12 boards with the Arduino. Now, I hope the screen is visible, right?
Yes, sir.
Okay. So now, first thing that you need to do is you need to go to the boards and you need to go to this board manager, because by default you will not be getting any ESP boards here. So here you need to search ESP8266 and you will find this ESP8266 boards by ESP8266 community. Then you need to click on install. You will find an install button here. You need to click on install and all the boards will be installed here. But you will not be able to see this ESP. Sorry. The first step is to go to file, click on preferences, and then you need to paste this link for ESP8266 and this link for ESP32. And why this is and from where you can get this link, you just simply need to type ESP8266 for Arduino IDE. Here, open any website and you will find this link. So once you have this link, only then you will be able to see the ESP8266 on boards manager. See, this is the link. This is the link that you need to copy and paste it in the preferences. Only then you can see this in the boards manager here. You will not be able to see this tab by default. You need to paste that link and then you need to go to tools, boards manager, and then you need to install the ESP8266 boards. Once you do this process, it will take some time and then you will be able to select the ESP8266 boards from here. Now to program the node MCU, we have to select the node MCU, which is this one, node MCU 1.0 ESP12E module. And there are some examples that are available for it. So why not just go to that part? Okay, let me quickly jump to the examples. So these are the examples for ESP8266. In the examples you can find, and whatever the libraries that you install, you will be able to find the examples from here as well. So the first one is ESP82 Wi-Fi. Okay, let's cut it down and make it very short so you guys can understand better. So for using the ESP8266 or ESP12 board, ESP12 and ESP8266, these are the same thing. So first thing, you need to include this library, ESP8266 Wi-Fi.h. Then the basic thing, you need to define the SSID. STA means station SSID. STA SSID is written here. STA, they are just defining at station mode because there are multiple modes in ESP. So they are using STA SSID. So this will be your SSID. Mine is, does it matter? And here you need to type the password. This is your router's SSID and password basically. Then you are just defining it again here. The SSID is a constant char array and it will take it from here. You know, examples are a bit complicated. You can easily just either simply you can use it directly from here as well. Hello. Am I audible?
Yes, sir,
Yes, sir,
you're
you're audible. You're audible, sir.
I don't know. It said you have been removed from this meeting. I don't know if you guys are feeling bored. You can just tell me. I can skip to the SmartDen.tech part. So basically you need to define the SSID and password here. No need of that as well. This is it. So basically what I'm doing right now is I'm just cutting down all the unnecessary part from the example so you guys can have a better understanding. Okay. Now we have selected the node MCU as the board. We need to select the COM port as well. First I need to connect the node MCU. It will show it here. So I have cut down all the unnecessary items, and the first line is ESP8266 Wi-Fi.h, which is the library file. Second one, we have defined the SSID and password. And in the setup part, we are creating we are trying to create a Wi-Fi connection. We are trying to connect the node MCU to the Wi-Fi. So these are the commands for it. So first one, we are again starting the serial monitor with this command serial.begin 115200. We are not printing anything, it's just the blank lines. Then we are printing connecting to, so it will be written on the serial monitor, and then we are printing SSID. So this SSID will be the same. So it will say connecting to, and then does it matter, this will be the name of your Wi-Fi network. Then we have Wi-Fi underscore STA, and Wi-Fi.mode is a function which will define the mode of node MCU. Either it has to be station mode or AP mode. AP means access point, in which your node MCU will act as a hotspot. This Wi-Fi.begin, this function is used to connect the node MCU to this SSID with this password. So this function will try to create a connection, and we are using while loop. while the Wi-Fi status, this will return a value, is not equals to WL underscore connected. There are some of the values that this function returns. And if it is not this one, it will print a dot after every 500 milliseconds. And if Wi-Fi is connected, that means this has returned this value. Then this will jump out of this loop and it will print the Wi-Fi connected, and it will also print the Wi-Fi IP address, its local IP address. Now let's select the COM port. The COM port is 3 in my case. In your case, it can be different. Again, I need to just upload this. We need to compile the sketch and then we need to upload it. Are you guys able to understand what is happening here?
Yes, sir.
Yes, sir.
Okay, let's wait for it to get completed and then we'll see how it creates a connection with the Wi-Fi. Okay, it says connecting and you can see that it is now uploading the sketch, writing at this address location. Okay, it says done uploading. Now again we need to open the serial monitor. Select the specific baud rate. And as you can see, it says connecting to does it matter. Does it matter is my Wi-Fi name. So first it performed this action connecting to, then it printed this does it matter from here. Then it has executed this line Wi-Fi.begin SSID and password. Until the Wi-Fi connection is not there, it is printing this dot until this WL connected status is achieved from this function. We are printing this dot, and then once the Wi-Fi is connected, we are printing Wi-Fi connected and the IP address. And with this function Wi-Fi.local IP, we are just printing the local IP address of this node MCU. So the node MCU is now connected to the Wi-Fi.
What
Now,
are that Wi-Fi dot mode is doing?
pardon, Wi-Fi dot mode. Okay, so Wi-Fi dot mode is defining the Wi-Fi this mode of this node MCU. There are different modes. Wi-Fi underscore STA means Wi-Fi is in this node MCU is in station mode. Station mode means it will connect to a Wi-Fi network. There is another mode, Wi-Fi dot mode. Wi-Fi underscore AP, which means this is access point mode. In station mode, this node MCU will connect to a Wi-Fi router. In access point mode, all the other devices can connect to this node MCU. It will act as a hotspot. In simple language, it will act as a hotspot. Wi-Fi hotspot. So in this case, we want to make it as a Wi-Fi station so that it can connect to the router that is there in our house. So we have used this Wi-Fi.mode function. Okay, so we have connected this node MCU to the Wi-Fi. Now let's focus on the MQTT part, how we can transfer the data to the cloud. That is the important thing. Now let's focus on libraries. Libraries let's see this ESP8266 Wi-Fi.h. This is a library for this node MCU, and there is a specific library for different things that you want to perform. Let's say for MQTT connection, there is a library by the name of pub sub client. To install a library in Arduino, you need to go to Sketch, click on include library, and then go to manage libraries. So it will take a little time. There are multiple ways of installing libraries. So this is, from Arduino IDE itself, you can install the library by this method. Go to Sketch.
ये मान के चल रहा है कि हम लोग को कोडिंग बहुत अच्छा आता है। हाँ, ये कोडिंग
नहीं आता तो यार मेरे को बता दो, मैं फिर बिल्कुल ही बेसिक से स्टार्ट करूंगा। अब ये सब फर्स्ट ईयर वाले अगर हो तुम लोग, और सेकंड थर्ड ईयर वालों के लिए फिर ये बोरिंग हो जाएगा अगर मैं बिल्कुल ही बेसिक से स्टार्ट करूंगा तो। या तो फिर पहले C++ थोड़ा सा कर लो। Do you want me to start from basics? Do you want me to tell you what is if else statement? You are engineering students, I guess.
We know that statement, sir.
Yes, sir, we are aware of
We
if
know
else.
the
No,
so we know
there
this.
is some guy who was saying that okay कि ये मान के चल रहा है कि हमको कोडिंग बहुत अच्छा आता है। नहीं, अगर this is very basic, my friend. This is literally very basic. Do you want me to continue? To be very honest, I don't feel like continuing this session right now. There are 150 students, 163. How many of you want me to continue? You can just raise your hands.
Sir, let them be whoever is thinking, sir. We are taking notes out of it.
Okay.
So please continue, sir.
Yes, sir, we are writing it.
Please continue.
Yes, sir. Please continue.
Thanks a lot. Thanks a lot. Okay, so we were on the library part. So if you want to install any library in Arduino IDE, there are different methods. First one is in the Arduino IDE itself, you need to go to the sketch and then you can include library with this library manager. Here you need to search for the library that you want to include. In our case, it is pub/sub client. So it will take a little time because every character you type, it will start searching accordingly. So I have to write very fastly. So there are thousands of libraries that you can directly install from here. So here is the pub/sub client. So ESP MQTT client is another library for ESP MQTT connection, and MQTT pub/sub client, this is another one. Okay. So this is the library that we need for our MQTT connections, which is PUB pub SUB sub CLIENT pub sub client by Nico Larry. So you need to click again on install button and this will be installed in your Arduino. And once the library is installed, you can explore the sketches directly from this examples. On the example, you will find this library. Here it is, pub/sub client and MQTT underscore ESP8266. This is the basic example. Again, I have to cut down a lot of things. So I've already made a sketch for you guys, which you can use. Let me just quickly show it to you. Okay, Arduino programs. I guess this will work.
Excuse me, sir.
Yeah, please.
Sir, instead of MQTT, I guess we can also transmit the data to the cloud over HTTP, right?
Yes, great. Whoever it was, I'm not able to see your name, but this is a great question. Why do we need MQTT at the first place? We can do that thing with HTTP as well, and which is again a great method. But there are, some advantages of using this MQTT. Uh, Previously, I've told that we can use Wi-Fi and GSM and LAN to connect our devices directly to the internet. Why do we have to shift to Zigbees and other things? Similarly, MQTT is a very lightweight protocol. It is very device friendly, and the speed, it is lightning fast. So it will directly publish the message without even, what happens in HTTP, you have to create a request and then the server will revert it back, right? It doesn't happen in MQTT. Once it is connected, it's lightning fast, and it's a very lightweight protocol, and you can connect multiple clients, thousands of clients directly to it. So that is the reason we shift to this MQTT, due to its very lightweight and very fast connection speed. Also, there are very good features in MQTT which we use when we need to develop a product. Those ACLs that I've told you, these are again, great feature. And once MQTT connection is discarded by any reason, rather if it is internet is not present, or device is getting damaged or something, we will get to know that something has happened because it has will messages in it. The moment you create a connection with the MQTT server, you can store a will message, so that when the device disconnects, the will message will get published on the server. The server will get to know that device is disconnected, and you can publish this information directly to the user who is using it. So I'll introduce these features in tomorrow's session, where we will be creating a complete project. So this is just to give you an introduction about the basic library itself. So I've created this sketch for you. You can use it with any MQTT server. So here again, I've included this ESP8266 Wi-Fi library to connect your ESP device directly to the Wi-Fi. Then we have used this PubSub client library, and there are two functions in it. One is callback function, second one is reconnect function. These are the two main functions of this library. Reconnect function is used to connect our device directly to the MQTT broker. Callback function is called when we receive any data from the MQTT broker. How many of you guys have heard about Node-RED? Do you have any idea about Node-RED? Computer science students. This question is for you specifically. Do you guys have any idea about Node-RED? Am I audible?
Yes, sir.
So do you guys have any idea? Yes or no? Just asking so that I can introduce it. And it is very beneficial for you if you are pursuing computer science and if you are interested in IoT.
So we just heard of it, but we
Okay.
don't
Okay.
in depth.
Okay. I'll show you what Node-RED looks like. So Node-RED is basically you don't have to program anything, and each and everything is via the nodes. You can connect and you can create flows directly by connecting the nodes. Let me just quickly start this service. It's a browser based service. I hope it will work here. So I'm starting this Node-RED just to demonstrate you guys how these things work, how the overall MQTT connection happens, and how you can control these devices directly from the internet. Let's wait for this service to get started, and till then let's jump onto the sketch. Okay, so I was talking about the two functions, in the PubSub client library. One is this callback function, another one is the reconnect function. Reconnect function manages your MQTT connection. If it is disconnected, it will try to connect again. And whenever you receive the callback function, whenever you receive any payload from server, you will call this callback function and you can perform actions on it. So this is the callback function, void callback, and here all the data is stored in this payload, and you can compare if whatever is coming, if it is, you know, is equal to a particular character, you can turn on the light or fan or whatever is there. So I'll come to it once. Let me check if it is running or not. Okay. Okay, it is connecting. So this is how Node-RED looks. You can create flows. So I've created a simple flow here. Let me go and add a new flow. So on the left side, you can see these are the node palettes. You can select nodes directly from here into your work area, and then you can work accordingly. Here we need to select a MQTT server. So let me quickly show you free MQTT servers. There are a lot of MQTT brokers that are available. You can use any one of them. So it's just for hopping the messages. Okay. Okay, so here is one, broker mqx.io. Let's try this server. This is the MQTT node, and what I'm doing here is I am creating a new server. So here it says server name. So I'm writing broker.mqx, sorry, from here. broker.mqx.io, and port number is 1883. So here is the broker and here is the port number. MQX. Let's see if it works. Done. Deploy. It says connected. That means this broker is working. Perfect. So we have selected a topic. Let's say test. Done. And there is this dashboard nodes. You need to install this dashboard nodes. If you guys are working on it and you want some guidance, you can directly message me on LinkedIn. And I have a special video series that I've made for this Node-RED as well. So this is just for, again, testing so that you guys can know what exactly is happening here. I'm adding one switch and I'll use this debug to print all the messages that are coming. Don't worry if you are not getting it. I'll explain each and everything. Let me first finish it. Confirm and deploy. So here we are creating a switch. Let's say LED, whose on payload will be A and off payload will be B, and the topic will be test. Done. Deploy. A and B is set, and okay. So this is the kind of dashboard that you have. Just a second. Here we have a single LED button that we have created here. LED which is connected to MQTT, and it is publishing, this LED button is publishing A when it is turned on, and it is publishing B when it is turned off on this test topic. Or you can also define the topic here. I am defining the test topic here. It is done. Deploy. Once you make any change, you need to hit on this deploy button as well. It is off, and you can see it is off here. QoS is 0. Done. Deploy. Here you need to change the MQTT server. broker.mqx.io. I hope it was the same. broker.emqx.io. Okay. Here you need to define the topic. I have defined it as test. This is for another topic if you want to define. So these are the things that you need to define. This is your SSID. This is your password for the SSID. This is your broker address. This is the topic that you want to subscribe on. Here we have created objects for the Wi-Fi client and a client for the PubSub client library. Void setup Wi-Fi. This is the function to establish a Wi-Fi connection. It says again same thing, connecting to this SSID with this begin function. If it is not connected, till that time we are printing this dot, and once it is connected we are printing the local IP. Once we are receiving any payloads from the callback function, we are printing that message arrived on this topic, particularly this topic, and whatever the message is, we are printing it here. Here are the if else conditions that you can change accordingly. If I receive A, B, C, what are the operations that I need to perform? If I receive A, I need to turn on the D4. If I receive B, I need to turn off the D4. Similarly, if I receive C, I need to turn off the D6. So that's customizable basically. So this is again second callback function that you don't need as of now, I guess. Reconnect function, I've told you that it is used to maintain the MQTT connection. While client.connected is, here we have not equals to, till the client is not connected to the MQTT, it will print attempting MQTT connection. Here we are defining the client ID as node MCU. Then we are using this function client.connect client ID. So this client, this node MCU will try to connect to the MQTT broker with this client ID, and it will subscribe to this topic. We are not subscribing on topic 1, we are just subscribing on topic we have already defined here on the top as test. Here it is. Else, if the connection is failed, it will get the state why it is failing. Now we have the setup part. We have defined multiple pins as input and output pins. So we are setting up the server. We have to set the server broker name and its port number. MQTT server we have already defined as broker.mqx.io, and then we have 1883 port number. This is the second callback function which we don't really need in this program, so you can just simply cut it off. There is the second callback. I'm just commenting it down, so if you want to use, you can use it. Loop is basically in the loop. We are checking if the client is not connected, call the reconnect function again and make sure the client is in loop. This p state equals to read data this one. This function is I have created specifically for manual switching as well. Just to give you an idea, I've created a sketch in which you guys can turn on the LED by manual adding buttons, by manual buttons, switch buttons, and as well as with the dashboards. So this function will let it synchronize the state of LED if you switch it accordingly with the buttons. So if you don't need it, you can just skip this thing. Let's try to upload it. If it gets uploaded, I'll show you how it works. Are you understanding these things, MQTT part and the programming of it? If you guys have doubts, you can just ask.
So this Node-RED service, is it free or we have to pay for
Yeah,
it?
it's completely free. It's completely free. You just need to install the Node-RED. You just Google how to install Node-RED in your PC and then it's good to go. And if you want, you can install this on any cloud platform so that you can access it from anywhere in the world. So this is just for your debugging purpose. So if you are looking to, making a career in IoT, Node-RED is something that you should look forward. Node-RED or Amazon AWS IoT Core, these kind of things, because it's an IoT platform complete developed by Amazon, and Node-RED is developed by IBM. Similarly, Azure IoT is developed by Microsoft. So you guys at least have a basic understanding on how these things work. What is MQTT and all these things, because interviewer will ask you question regarding these things only. Whatever I've told you in these 2 days, I'm pretty much sure 80% of your basic IoT knowledge and basic interview questions are from these 2 workshops. Tomorrow we'll just be making a project. But the theory part that we have done and we have covered, majority of the MQTT questions and basic things will be asked from these things. Okay, it says done uploading.
Any other doubts, guys?
Pardon?
Excuse me, sir.
Yeah.
Sir, basically, I'm working on this project of mine. So basically, I have this 200 different houses, and they have this users, and I need to basically send the data of a load sensor to the web app that is installed in the user mobile. And at the same time, I need to send that data of the same users to a cloud so that it can be monitored by an authority.
Perfect.
So, but the thing is that it's basically impractical to have 200 different web pages based on different IPs, right?
Absolutely.
I'm stuck where, I mean, what to do now? I mean, should I shift to MQTT because I haven't learned more about MQTT as of now?
Obviously, you should shift to the MQTT where each and every user will be treated as a client and they will be publishing the data on your this main central server, and from there you will be controlling it. I mean, it's a lengthy topic. If you want to discuss directly with me, you can just drop me a message on LinkedIn.
Yes, sir. Sure, sir.
Yeah, so it's a good project basically. So you can also achieve it with SmartDen.tech, and I'll show you tomorrow
Okay,
when we'll be doing it.
Yeah.
Okay, so if you take a look, we have created a Wi-Fi connection, Wi-Fi connected. This is the IP and attempting MQTT connection, and it says it's connected. Now, since we have the MQTT connection, let's see if it is working. As you can see, it says message received A. I have triggered a message from this Node-RED and I've received it on my Node MCU. So just to compare it, I'll just put it right here, and this is the Node-RED, and here if I turn off the LED, and just to demonstrate you guys, just give me a second. Let me know if you guys can see me.
Yes,
Yes, sir.
Yes, sir. Yes, sir.
You see that blue LED over here?
Yes, sir.
Okay. I can control it directly from here. Are you able to see this?
Yes, sir.
Yes, sir.
I am controlling this LED on the Node MCU from the Node RED. At the same time, I'm receiving the messages and I'm printing it on the serial monitor. These are the same messages that we are receiving, A, B, C, D, whatever the switches that you want to make. So this is how MQTT works. You can see how fast it is. Is it visible properly?
Yes, it's visible.
So that's how fast it is. You can see it's, I mean, I'm doing it manually, but 100 milliseconds it can be done. So yeah, that's the overall purpose of today's session, to make you understand about MQTT and about Node MCU and Arduino basic programming. I hope you guys enjoyed it. एंड भाई
Yes, sir.
जिसको थोड़ा सा बेसिक और जानना है प्लीज उसको बोलना कि वो मेरे को पर्सनली मैसेज कर ले, मैं थोड़ा सा वीडियो शेयर कर दूंगा.
Thank you, sir. Is there any doubt to any other people also?
So, what is the disadvantage of MQTT protocol in
That's a
terms of
tricky one.
security? In terms of security.
Security point of view, I'm not sure. I haven't heard about any disadvantages of MQTT, but it's a good question. I haven't uh, seen any of the disadvantages till yet. I'm using it for my complete projects and all the other things, but we haven't faced any issues with the MQTT yet. Each and everything is very much secured. Even each and every client can be given its own username and password, and which also can be encrypted, and the payloads that we send, that are also encrypted. So and the newer version of MQTT, the one we are using right now is MQTT 3, and the latest one is MQTT 5, which is also more secure. But we haven't faced any issues with the MQTT yet.
Okay, then it is 100%. It is having secured.
Ma'am, I would not see. This is a very dicey situation for me as well, because there is no such thing which is 100% secure. And but as of now, I am not sure if I'll be able to tell any disadvantages of using MQTT in the IoT, because it's specifically designed for IoT.
Okay, okay.
Yeah.
Thank you.
Any other doubt, guys?
Sir, I had this one doubt.
Yeah, sure.
Sir, if we talk about IoT, there is a kind of a question arising in my mind regarding privacy. I mean, how do you, if there is an interconnection of different devices between each other, even if you have a broker or so, the privacy part is a kind of a question where you see where leaking of this information is pretty redundant and easy for anyone to just take the note of some sensor data regarding or belonging to some other person. So
In that case, I've told you about the ACLs previously, which is called the access control list, and there are few measures. See, data privacy is a concern in IT. It's not in IoT. It's in IT. It's a major concern in IT. You guys must have heard about various news. Once in a while we heard that okay, some $1.5 million data is leaked, and this much data is leaked. Their databases are corrupt. So these are the things that kept happening in IT industry. So data privacy is more of like how you design your architecture. It's not basically depending on the technology. It's more on how you design your architecture, how you restrict the user to access your network. So it's more into that part. I would not say कि आपका सारा डेटा ही अनसिक्योर है. आप अगर प्रिवेंटिव मेजर्स फॉलो कर रहे हो और आपका जितने भी आपके डिवाइसेस हैं दे आर एनक्रिप्टेड, आपका जो कनेक्शन है दैट इज एनक्रिप्टेड, यू आर यूजिंग एसएसएल सिक्योरिटीज, जो बेसिक एक स्टेप बाय स्टेप प्रोसेस होता है किसी भी चीज को डेवलप करने का, और उसके जो सिक्योरिटी चेक पॉइंट्स होते हैं, इफ यू आर फॉलोइंग ऑल दोस थिंग्स, देन द चांसेस ऑफ these data leaks, data breaches, these are very low. मोर ऑफ जो एक्सेस कंट्रोल लिस्ट जिसकी मैं बात कर रहा था, दिस इज अ काइंड ऑफ लिस्ट वेयर यू रेस्ट्रिक्ट द यूजर टू गो इनटू योर नेटवर्क, but you can access that network, but your user, the end user, will have access to the stuff that is limited to him only. He will not get any other user's data. So it's more on the architecture side, I would say.
Okay, sir. Understood. Thank you.
Okay, so thank you so much, sir, for this amazing session. It was really interactive and a great session. And
Thanks
it
a lot.
was a complete hands-on experiencing for us also, and we listened a lot, understanding, and implementing with you at the same time. Thank you for this wonderful session, sir. And I would like to request everyone to please turn on the cameras for having a group photo. Thank you.
Yeah, let's have this thing as well. I hope you guys are learning out of it. Like, it's not boring for all of them. I mean, like, there are people, but I'm trying to make it interactive for everyone.
Yes, sir, it has been a great session, sir.
Thanks a lot, Gaurav. Thanks a lot.
So do share your YouTube channel as well.
Is the chat section open? You guys can directly search on YouTube, Shrey Sharma space IoT. You'll find me somewhere. Or you guys can just Google it. You'll find it.
Sir, can I ask a general question, sir?
Yeah, sure.
Actually, I'm doing my research. Just started this week only after my coursework. So my guide has told me to concentrate on security issues in IoT application layer.
Okay.
So in application layer, I thought to find out what are the disadvantages of those protocols which is being used in the application layer, IoT application layer. So one thing is this MQTT only is the most used protocol.
Yes,
so I
ma'am.
thought what can be the disadvantage of MQTT so that I can just work on it.
Okay. I'll love to have a research on this thing as well. And for that application layer that you are talking about, it is more like TCP/IP, UDP, and COAP. So those are the things that you must consider while talking about the application layer in that particular segment as well. Mostly, if we talk about product range and if we talk about what industry uses, it's more of like MQTT side of thing. But there are some other protocols as well which are based on UDP, which is majorly used in
application layer.
Yeah, so COAP is one protocol there, which is depending on UDP protocol.
That's why I raised that question. What can be the disadvantage in MQTT?
I'll surely take a look into it, and if I find something, I'll get back to you.
Okay, thank you so much, sir.
So I guess
Okay,
it's done for the day, I guess.
Yes, thank you, sir. So lastly, I would like to thank all the participants for joining the session and making it so lively. We'll be closing this session now, and thank you so much to everyone. Thank you. Thank you. Have a nice day.
Thank you, sir.
Thanks a lot, everyone. Thank you so much.